Hello everyone. Thank you for staying to the end of the day. If you're here to see the Minecraft movie, it is after this, so you just have to listen to me for the next 20 minutes and then you get what you were looking for. First things first, business as usual. If you want to ask questions, probably know what to do by now. There's the QR code. I'll give you 10 seconds to scan it. 10 seconds up. Right. Firstly, who am I? I am Ryan. This is probably the biggest I've ever been now, being on a cinema screen like that. I exist at LMAX in London, and today or yesterday you've probably heard a lot of talks from some people known as Java champions. I'm part of a far less exclusive club. I'm a Java chump. You are all invited to join as long as you are not a Java champion. Sorry, Ags. A few conditions before we start, just so everyone's aware. I am not an expert. Please not expect any really low-level threading stuff in JVM and how exactly all works, because I don't know, but I'm just here to share my opinion. So don't take any of this personally. All thoughts presented my own. Terms and conditions may apply. Please see the build pay admission. No humans or animals were harmed in the making of this presentation yet. So, what is your least favorite interview question you've ever been asked? So this talk is inspired by a question I got asked in an interview, in fact, at my current job, and it was, what is your favorite number of threads? That really threw me off. I do not have any personal emotional attachment to threads. I don't even have a favorite number, never mind number of threads. So I didn't know what to say, things going through your head like as many as you want, as many as you need, 4. Maybe some of you misheard me and are now trying to think of how many people named Fred you can think of, or maybe your favorite musical number by Freddie Mercury. And to answer the last two questions, it's 3.1 million people and Radio Gaga. But I didn't like this question, and I got the job, and I decided that I would like to get this question removed. But to be able to remove a question, I feel like you need to answer it fully. So I went on a quest to get to the bottom of what is the best number of threads. Now, I scoured the internet for this. I was on blogs, I was on forums, I was all over the place looking for where possibly you can find the best number of threads. And no one could agree. Even UK retailer M&S and Good Housekeeping had opinion on number of threads. Admittedly, that's about bedding, but thread counts are still numbers of threads. So I went to all-knowing source of truth and the place where no lies were ever told, ChatGPT. And since I believe in 3 things, good manners, keeping my job in the incoming AI Armageddon, and causing Sam Altman a lot of money, I made sure to be very, very polite. So I asked, please tell me the best number of threads. Thank you, please, please, please. And I got a response like this, as concise as ever. It gave me a lot of detail, blah, 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 blah. The answer is, it depends. Thank you. After a bit more drilling down, we got to this answer. So for CPU-bound operations, number of cores plus 1. For I/O-bound cores times 1 plus wait over service time threads. And, it seems reasonable, but I'm not going to trust it at blind faith. I'm going to do some benchmarks. And I've never written benchmarks before. I know I work at a company that talks about their performance testing and low latency, whatever. I don't do any of that stuff, so I wrote my first benchmark. Here it is. Don't worry, you don't need to read it. All I'm going to do is initialize a executor pool of threads with different numbers, and I'm going to do some work, and I'm going to see how long it takes. I ran this against a machine with 8 cores and plotted the results. Here are some results. So based on what ChatGPT told us, we're expecting 9 threads to be the best number of threads. I didn't actually do 9 because I misread it and read it as number of cores. So actually I've got 8. So expect between 8 and 12, and you can see around there it plateaus at 291. And when we get to about 100, it starts to tail off again. But what about for IO-bound things? It said, oh, sorry, forgot. If you like graphs, here's a graph. What about IO-bound things? There's a formula. So I had 8 cores, a service time of 2,250 milliseconds, and I put in some fake IO of 5 seconds. And that gave you an estimate of about 26 threads. So I put that through my benchmark. I even changed to light mode this time. And as you can see, somewhere between above 24, it starts to plateau, and we don't seem to see much improvement. So maybe ChatGPT was right. You know, it had some pretty good estimates. It's doing some stuff. But what about virtual threads? You know, we're not done yet. We can't just answer there and then finish the talk. As much as you'd all like to go home, I'm not going to let you leave yet. We're going to talk about virtual threads. And I pose to you, what is a virtual thread? What actually makes it different to a system thread? And to boil it down, there's a few key differences. It's managed by the JVM instead of the OS. It's a lot more lightweight, so it's only a few kilobytes, and compared to about a megabyte for normal system threads. But what it doesn't do, it doesn't give you more cores. So it's still operating on the same machine, it's still using the same number of cores. So in reality, it's great for heavy I/O tasks because you can do all the hot swapping and context switching between all the different threads when you're waiting for things to happen. But for CPU-bound tasks, it's not that much faster. I've added an asterisk there after going to a talk yesterday about virtual threads. I didn't know this. It is a bit better if you're doing millions of very small CPU-bound tasks, because you benefit from the smaller overhead of scheduling and context switching. So we're not done yet. Given that formula, I live in a containerized world now. We use millicores. Do I need millithreads? Maybe. But what is actually happening when I say millicores? Well, you're not actually splitting a core into different cores. You're splitting time. So if I gave it a whole 1,000 millicores, for every unit of time, it would use one whole core. So it would pack the work together like this. If I was using 500 millicores on one core, it would use half the time, and then it would just do something else for the other half, and so on. And if I had multiple services and multiple cores, it could look like something like this. It could split all over the place. It can fulfill its budget, and it will just wait around for the next unit of time before doing the work. So you're not actually gaining anything, you're losing anything. Maybe you're secretly getting more cores if your piece of work happens in a very short amount of time and you're doing it in that first 25 milliseconds, like on that top row, and you don't need the rest of the unit of time to be able to do it. But we're doing a lot of talking about performance here, and performance is not the only thing. What are we actually trying to optimize? Why not we use one? Maybe many threads, maybe more performant, better throughput, or whatever you're doing. But what about one? Now, at the moment, although, as I said, AI Armageddon is happening and coming for our jobs, we are still the writers and readers of code. We still need to understand what's going on. And unfortunately, we're not very good at that. We have very, very simple brains. We're not very smart. And unlike computers, we cannot multitask. So we can only understand code in one thread at a time because, simply put, we are single-core computers. If we weren't single-core computers, we could have all 4 talks in this room at the same time, and you'd understand everything. But we're not. You need to listen to one thing at a time because we're simple. To be confident in your code, you should be able to understand your code. A multi-threaded code is hard to understand. You may be gaining performance, but you're losing out on many other things in your knowledge of how things work. And hard to understand code is hard to test, hard to read, hard to maintain and collaborate on, keep secure, improve, refactor, progress, debug. I'm sure you've looked at some code and there's been all sorts of keywords all over it of volatile and synchronized and everything, and there's thread pools and there's virtual threads and there's executors all over the place, and you're trying to figure out what order a thing's going to happen in, and you just don't know because you can't know. You don't know what's happening in the background in reality that's putting those things in different cores and putting them on different threads. One thread It's very easy to understand because you can follow it through. You can see what's happening. And I talk a lot about performance earlier, saying maybe many threads are more performant. Well, in reality, when you're at ultra-low latencies, one thread is actually faster as well, because you no longer need to worry about synchronized blocks. You no need to worry about data structures and manipulation between them and how memory has been handling, or just the general orchestration of the threads. But the more observant of you may have noticed that I never actually answered the interview question here. I've been talking about the best number of threads. The real question was favorite number of threads. So what is my favorite number of threads? If we follow the logic of many threads are okay, one thread is better, then surely no threads. Because no threads means no work, and I can fulfill my dream of becoming a goose farmer and leave all this world behind. Thank you very much. Ooh, how do I switch over to... Here we go. Oh, I'm on the wrong screen. What is a thread? Good question. It's whatever you want it to be, really. It is a... Oh, man, you put me on the spot here. It is a place where work is happening. There you go. An office is a thread. Thank you very much. I'll assume there's no more questions. Go enjoy the party.